we're going to have a look at how to divide terms, okay, which is quite straightforward once you get your head around the expanding version of each of the examples. So let's have a look at the first one. So again, I'm going to start off with expanding, and by the end, I'm going to get rid of the expansion and show you how to do it by just looking at the expression. So 20 times p divided by 5. Okay, so first of all, what we're going to do, 20 divided by 5. Deal with the numbers first. Okay, now 20 divided by 5 is 4. Okay, so we've actually removed the fraction. Now, the only pronumeral that we're left with is p. We can't do anything with it. Okay, so it's 4 times p. So 4p. Again, same thing. Divided by 8 times y. Now, again, deal with the numbers first. 24 divided by 3. Now, whenever so you've got to think of the pronumerals as being a certain number. So if I associate the number 2 with y, each of these is going to be 2. So 2 divided by 2 is 1. So whenever you're dividing the same pronumeral by itself, it's always going to equal 1. It has to. Whenever you divide the number by itself, it equals 1. Now I don't need to write 1, okay, because 3 times 1 is going to be 3. So my answer is left is 3. What I've essentially done is simply cancelled each of these out. So you can put a line through each other. Now let's look at a similar example, okay, with 3 over 4 times m times n. Okay, now this is a little bit tricky in the sense that minus 2 divided by 4. Now if you're a little bit stuck on these type of fractions, put into your calculator as such. Okay, so you've got minus 1.5. Now this minus half. This can actually be written as well like so. Now I've got two of the same pronumeral, which I cross out. I'm left with the pronumeral of n as on the denominator side. Okay, so at the bottom. I have to leave it there. I can't just shove the n up here. It has to be on the same side when you're left with a fraction. So I'm going to write it down there. So minus 1 over 2n. Okay, so that's my answer. Coming down over here. Okay, so this will be the last one I expand. Times a times b over 3 times a. So let's just cross those two out. Okay, they've cancelled each other out. However, I'm left with these. I can't cancel these out. There's nothing on at the bottom for me to divide by itself, which means I'm going to leave them up there. 12 divided by 3, which is 4. A, b. If this was a fraction, this a and b would be put up with on the numerator side. I wouldn't be able to put it at the denominator side, okay, at the bottom. So just remembering that whenever you're left with a fraction, the pronumeral has to stay on the same side as it is in the question. Okay. Luckily here we do not have a fraction. Makes it a little bit easier. We're going to have a look at this. Okay. 3 divided by 3. Deal with the numbers first, which is 1. I don't need to write 1. Okay. So if I've got a to the power of 2, and I've got a essentially to the power of 1, what I can do is 2 take away 1. 2 take away 1 is 1. I've only got 1a there. Now b to the power of 2 and b to the power of 2. Now these are exactly the same, which means they cancel each other out. C divided by c, again, same trick. Okay, they cancel each other out because they're the same pronumeral. These aren't the same pronumerals. So it would be like writing a times a divided by a. I can cancel 1 out and I'm left with 1. 1a. Now that's our entire answer based on this.